It's a strange thing, isn't it? We spend so much time focused on the immediate, the quarterly earnings, the political squabbles, the latest social media drama, and yet the single greatest threat to our civilization, the one thing that could wipe the slate clean in an afternoon, is something we barely talk about. It's the cosmic game of Russian roulette role-playing, and the chamber is loaded with rocks and ice moving at unimaginable speeds. I speak to the Rogan in our 3+ hour podcast about a lot of things, from the future of AI to the mechanics of a Mars colony. But when we started talking about 3I, Atlas, the interstellar visitor, the conversation took a very sharp turn into the realm of the truly existential. And that's where the focus needs to be. Not on whether this specific comet is going to hit us. The current data, thankfully, says no, it's a near miss, a cosmic flyby, but on the fact that the universe is actively trying to kill us, and we are doing almost nothing about it. Think about the sheer scale of the threat. We're talking about objects that can range from a few hundred meters to several kilometers in diameter. The one that wiped out the dinosaurs, the Chicxulub impactor, was about 10 to 15 kilometers across. It hit with the energy equivalent of billions of Hiroshima bombs. It didn't just kill the dinosaurs, it fundamentally reshaped the planet's climate for millennia. It created a nuclear winter scenario, but with rock vapor and soot instead of fallout. Now, I will talk about 3I Atlas. It's an interstellar object. That's the key distinction. It didn't grow up in our solar system, orbiting the sun in a predictable, well-mapped path like the asteroids in the main belt. It came from somewhere else, from another star system entirely, flung out into the void by some gravitational slingshot eons ago. That means its trajectory is fundamentally different. It's coming in fast, at a high inclination, and it's not following the nice, neat, elliptical orbits we've spent decades mapping. The initial estimates for 3I Atlas's nucleus size were wide, but even at the lower end, a few hundred meters, you're talking about a city killer. At the higher end, a few kilometers, you're talking about a continent killer, a civilization ender. And the speed interstellar objects move much faster relative to us than our local neighborhood rocks. The kinetic energy scales with the square of the velocity, double the speed, quadruple the destructive power. This isn't just a bigger bullet, it's a hypervelocity bullet. The fact that we only detected it relatively recently, and that its path was initially so uncertain, highlights the terrifying gap in our planetary defense system. We have projects like Atlas, the Asteroid Terrestrial Impact Last Alert System, which is doing heroic work, but the name itself is telling. Last Alert System. It's designed to give us a few days, maybe a few weeks of warning for smaller objects. For something like 3I Atlas, an interstellar object, the warning time could be measured in months or even less, depending on its size and how dark it is. And what do we do with that warning? That's the terrifying question. If we find out tomorrow that a 5-kilometer object is going to hit the Pacific Ocean in 6 months, what is the plan? The honest answer is we don't have one that works. We have theoretical concepts, kinetic impactors, gravity tractors, nuclear options, but none of them are sitting on a launch pad, ready to go. None of them have been tested on a real-world civilization-ending threat. It's all PowerPoint and white papers. The reason I bring this up, the reason I felt compelled to discuss it with Rogan, is because it's the ultimate failure mode for humanity. We're trying to get to Mars to become a multiplanetary species, precisely to hedge against this kind of existential risk. But if we don't survive the next century on Earth, the Mars project is moot. It's a race against the clock, and the clock is ticking on a cosmic scale. We need to treat planetary defense with the same urgency we treat climate change or a global pandemic. It's not a fringe concern, it's the foundation of our continued existence. The physics of annihilation, speed, size, and the energy equation. Let's dive into the cold, hard physics of an impact event, because the numbers are what truly convey the gravity of the situation. When we talk about an asteroid or a comet, we're not just talking about a big rock. We're talking about a massive amount of mass moving at orbital or in the case of 3I, Atlas, interstellar velocities. The energy of impact, the destructive power is governed by the kinetic energy formula, $E, K equals mv, $2, mass times velocity squared. The square of the velocity is the critical term here. A typical asteroid in the main belt might be moving at around 20 kilometers per second relative to Earth. An interstellar object like 3I, Atlas, because it's not bound by the sun's gravity and is just passing through, can be moving much faster, say 50 to 70 kilometers per second. Let's take the conservative end, 50 kilometers per second, which is 2.5 times the speed of the typical asteroid. Squaring that, you get a factor of 6.25 times the energy for the same mass. This is why 3I Atlas is so terrifying. It's not just the size, which is significant, but the speed. It's a relativistic punch. Let's put some numbers to it. A 1 kilometer diameter stony asteroid has a mass of roughly 2 trillion kilograms. Hitting at 20 kilometers per second, the impact energy is in the range of 100,000 megatons of TNT. That's enough to vaporize a large chunk of the Earth's crust, create a crater 15 to 20 kilometers wide, and cause global devastation through tsunamis, earthquakes, and atmospheric shock waves. Now, take 3I Atlas, potentially a few kilometers in diameter, and let's assume a conservative 3 kilometer size. That's 27 times the mass of the 1 kilometer object. And let's assume a velocity of 50 kilometers per second, which is 6.25 times the energy factor. We multiply those two factors, $27 times 6.25, approx $168.75. You're looking at an impact energy nearly 170 times greater than the 1 kilometer asteroid scenario. We're talking about an impact energy in the range of 17 million megatons of TNT. To put that in perspective, the largest nuclear weapon ever detonated, the Tsar Bomba, was about 50 megatons. This impact is 340,000 times more powerful than the largest bomb ever built. The immediate effects are catastrophic. If it hits land, the impact site is instantly vaporized. The shockwave travels faster than sound, flattening everything for hundreds of kilometers. The heat pulse, the thermal radiation, ignites fires across a massive area, but the real killer is the ejector. Material from the impact site is thrown up into the atmosphere, where it re-enters the atmosphere globally, creating a rain of incandescent, superheated rock. This is what ignites global firestorms. The soot and dust from these fires, combined with the vaporized rock, block out the sun. This is the impact winter. Photosynthesis stops. The food chain collapses. The surface temperature of the Earth plummets. This is the extinction level event. It's not the initial blast that kills most life. It's the subsequent long-term climate collapse. And if it hits the ocean, which is more likely given the Earth's surface is 70% water, you get a different but equally devastating scenario. The impact creates a massive mile-high tsunami that travels across the ocean at jet plane speeds. It inundates every coastline on the planet. But even worse, the sheer volume of water vaporized and thrown into the atmosphere acts as a super greenhouse gas, potentially leading to a rapid, catastrophic warming period after the initial dust settles. The planet's climate system is completely broken. This is the reality of the threat. It's not a movie plot. It's a statistical certainty that an object of this size will eventually cross paths with Earth. The question is not if, but when. And the fact that we have the technology to prevent it, but lack the political will and the deployed infrastructure, is frankly an indictment of our species' short-term thinking. We are literally gambling with the future of all life on Earth. The interstellar wildcard, Y3, I, Atlas changes everything. The discovery of 3I, Atlas, and before it, Oumuamua and Comet Borisov, marks a fundamental shift in our understanding of the cosmic threat. For decades, planetary defense focused on near-Earth objects, or NEOs, which are asteroids and comets that orbit the Sun but come close to Earth's orbit. These are the local threats. We know where they are, we can track them, and we have a pretty good idea of their orbits for the next century. The work done by NASA's Planetary Defense Coordination Office and other global efforts is focused on cataloging 90% of the large NEOs. That's a solvable problem, and we are making progress. But 3I Atlas is different. It's an interstellar object, or ISO. It's a traveler from the deep black, an object that has been ejected from another star system and is just passing through ours. This changes the threat profile in 3 critical ways, which I discussed at length with the Rogan. First, detection and warning time. Local NEOs are in stable, predictable orbits. We can find them years, even decades, before they pose a threat. ISOs, by definition, are not. They are moving on hyperbolic trajectories, meaning they enter our solar system, swing around the sun, and leave, never to return. They are only visible when they get close enough to be illuminated by the sun, and by then they're already moving incredibly fast and are on a collision course. Our current detection systems, while good for local threats, are not optimized for these high-speed, high-inclination interlopers. We are effectively blind to them until they are almost upon us. Second, velocity and energy. As I've already detailed, the relative velocity of an ISO is significantly higher than a local NEO. This is the $V, $2 factor in the kinetic energy equation. The destructive potential is exponentially greater. A smaller ISO can pack the punch of a much larger NEO. This means our threshold for what constitutes a dangerous object needs to be recalibrated downward for ISOs. A 100-meter ISO could be as dangerous as a 500-meter NEO. Third, composition and structure. This is where the speculation and the really interesting, almost unsettling part of the conversation with the Rogan comes in. We know very little about the composition of ISOs. 3I Atlas is a comet, meaning it's largely ice and rock. But Oumuamua, the first one we found, was a complete enigma. Its shape, its non-gravitational acceleration, it behaved like nothing we had ever seen. It was so strange that even the most conservative scientists, like Avi Loeb at Harvard, have seriously entertained the possibility of it being an artificial object, a piece of alien technology. Now, I'm not saying 3I Atlas is an alien spaceship. The data suggests it's a natural comet. But the point is, we don't know these objects are samples from other star systems. They could be made of materials we haven't encountered with densities or structures that defy our models. If an ISO were made of, say, a super dense metallic alloy, a much smaller object could deliver the same civilization-ending impact as a much larger, less dense rock. The uncertainty is the enemy. The current planetary defense architecture is built on the assumption of local, predictable threats. The interstellar objects are the ultimate wildcard. They represent the true Great Filter scenario, the one that could end the human experiment before we even get off the planet. This is why the focus needs to shift. We need a dedicated, global, and highly funded program to track ISOs. We need space-based telescopes, perhaps orbiting beyond the Earth, specifically designed to look for faint, fast-moving objects coming from the outer solar system. We need to be able to detect them when they are still 5 or 10 astronomical units away, not when they are already inside Jupiter's orbit. And most importantly, we need a deployed, ready-to-go deflection system. Not a paper plan, but a system of heavy-lift rockets. Starship, obviously, is the only vehicle with the payload capacity to do this, with a variety of deflection payloads ready to be integrated and launched within weeks. If we have a 3-kilometer object coming at us, a kinetic impactor won't work. You need a nuclear option not to blow it up, which would just create a shotgun blast of smaller, still lethal objects, but to use the energy of the blast to vaporize one side of the object, creating a rocket-like thrust that nudges it off course. This is a complex, high-stakes engineering problem, and we need to solve it now, before the next 3I Atlas shows up with a bullseye on our planet. The failure of imagination, why humanity is unprepared. The most frustrating aspect of this whole situation, and what I found myself emphasizing to the Rogan, is the profound failure of imagination that permeates our institutions. We are a species that has mastered nuclear fission, sequenced the human genome, and put rovers on Mars. We are capable of solving this problem, yet we choose not to. Why? Because the threat is not immediate, and it's not political. A politician can't get reelected by promising to spend billions on a threat that might materialize in 500 years. The human brain is wired for immediate, local threats, the lion in the grass, the rival tribe. It struggles to comprehend and prioritize a low probability, high consequence, global and long-term threat like an impact event. It's the ultimate black swan event, except we know this one exists, we just don't know when it will land. This is where the concept of the existential filter comes in. It's a theory that tries to explain the Fermi paradox: if the universe is so vast, where is everyone? One possible answer is that advanced civilizations inevitably hit a wall, a great filter, that prevents them from becoming truly interstellar. That filter could be self-destruction through war or AI, or it could be a natural cosmic event, like a supervolcano, or most likely a planet-killing impact. If we, as a species, fail to solve the planetary defense problem, we are proving that the impact event is our great filter. We had the knowledge, the resources, and the technology, but we lacked the foresight and the collective will to act. That would be the most pathetic, self-inflicted extinction in the history of the universe. Consider the current state of our defense infrastructure. We have a handful of ground-based telescopes, a few dedicated surveys, and a small underfunded office at NASA. The total global budget for planetary defense is a rounding error compared to military budgets or even the cost of a single major sporting event. It's a joke, a cosmic tragedy waiting to happen. The DOT mission was a fantastic proof of concept. We successfully hit a small, non-threatening asteroid, Dimorphos, and altered its orbit. It proved the kinetic impactor concept works for small objects. But DOT was a one-off, years in the making, and it used a relatively small spacecraft. Scaling that up to a 3-kilometer comet moving at 50 kilometers per second is an entirely different engineering challenge. You need a much, much larger mass, or a much, much higher velocity, or a completely different approach. This is where the Starship architecture becomes not just a vehicle for Mars, but the ultimate insurance policy for Earth. Starship is the only vehicle currently being developed that can lift the necessary mass, hundreds of tons, to rapidly deploy a serious deflection system. Whether it's a massive kinetic impactor, a gravity tractor with enough mass to actually pull a large object, or the nuclear option, Starship is the enabler. Without it, we're stuck with the current inadequate launch vehicles that can only deliver small payloads, which are useless against a civilization-ending threat. The failure of imagination extends to the political and regulatory environment. Imagine the international treaties you'd have to navigate to launch a nuclear device into space, even for the purpose of saving the planet. The Outer Space Treaty prohibits the placement of nuclear weapons in space. While a deflection device isn't a weapon in the traditional sense, the optics and the legal hurdles are immense. We need to have these conversations now, not in the 6 months of panic after a discovery. We need a global UN-backed protocol for planetary defense that bypasses national politics and allows for immediate, decisive action. We are living in a moment of profound technological capability, but we are paralyzed by institutional inertia and a lack of collective long-term vision. The universe doesn't care about our quarterly reports or our political squabbles. It operates on the cold, hard laws of physics, and those laws dictate that if we don't build the shield, we will eventually be struck down. The 3I Atlas flyby is a warning shot, a cosmic reminder that the universe is not a benign place. We need to heed that warning and build the necessary infrastructure before the next, more accurately aimed object arrives. The Starship shield, from Mars colony to Earth's insurance policy. The solution to the existential threat posed by objects like 3I-ATLS is not a single technology, but a complete, integrated, and rapidly deployable system. And at the heart of that system is the Starship. I speak to the Rogan about this all the time because it's the core thesis of SpaceX. The vehicle that enables humanity to become multiplanetary is also the vehicle that saves the single planet we currently inhabit. Let's break down why Starship is the only viable solution for a rapid response planetary defense system. First, payload mass and volume. This is the most critical factor. A civilization-ending impactor, a 3-kilometer comet, requires a massive amount of energy to deflect. A small kinetic impactor, like DART, is a mosquito hitting a freight train. To deflect a large object, you need a massive kinetic impactor, a Starship-sized chunk of metal, or a payload of hundreds of tons of material. Starship is designed to carry over 100 metric tons to orbit, and potentially much more in an expendable configuration. No other rocket in existence or development comes close to this capability. This mass allows for a serious, effective kinetic deflection, or the deployment of a truly massive gravity tractor. Second, rapid reusability and deployment. The current generation of heavy lift rockets takes months, sometimes years, to prepare for launch. They are expensive, single-use assets. If we get a 6-month warning for a 3I Atlas-sized object, we don't have time for that. We need a system that can be fueled, loaded with a payload, and launched within weeks, if not days. Starship is designed for rapid reusability, with a goal of turning around in hours. This is the key to a true rapid response system. We can have a fleet of Starships, or at least a few dedicated ones, sitting on the pad, ready to be configured for a deflection mission. Third, the nuclear option enabler. Let's be honest, for the largest, fastest moving objects, a nuclear deflection is the only option that provides the necessary energy in a short time frame. The goal is not to detonate the device on the object, which would shatter it into a cloud of smaller, still lethal fragments. The goal is to detonate it near the object, vaporizing a layer of the surface. This vaporized material acts like a rocket plume, pushing the object off course. This requires a large, complex nuclear device and the shielding and delivery system to get it there. Again, Starship's massive payload capacity is the only way to deliver this kind of complex, heavy system to an intercept trajectory quickly. Fourth, in space refueling and trajectory correction. An interstellar object like 3I, Atlas is moving incredibly fast and is often on a high inclination trajectory. Intercepting it requires a massive change in velocity, or delta V, for the interceptor spacecraft. This is where Starship's in-space refueling capability is revolutionary. We can launch the Starship, refuel it in Earth orbit, and then use that massive fuel load to execute the high energy burn required to intercept the object far from Earth. This extends our effective range and gives us more time to execute the deflection maneuver. The Starship is not just a transport vehicle, it's a platform for planetary survival. The development of the Mars colony, the creation of a self-sustaining civilization off-world is the ultimate hedge, but the Starship itself, as a launch platform, is the immediate shield. We need to accelerate its development, and crucially, we need to start designing and testing the actual deflection payloads that will sit inside its fairing. This is a global imperative. The cost of a fully deployed, Starship-enabled planetary defense system is trivial compared to the cost of a single major impact. It's an investment in the continued existence of the human race. And that, I think, is a pretty good return on investment. The conversation I had with Rogan was about raising the alarm, about moving this from a theoretical concern to a practical engineering challenge that we must solve. The technology is within our grasp. The only thing missing is the collective will to execute. The long game multiplanetary life as the ultimate defense. While the immediate threat from objects like 3I Atlas demands a rapid Starship-enabled defense system, the long-term ultimate solution to the existential risk is to become a multiplanetary species. This is the core mission of SpaceX, and it's the final, most important point I make when I speak to the Rogan. Planetary defense is a necessary, but ultimately temporary solution. It's a shield. But shields can fail. The universe is vast, and the number of potential threats, supernovae, gamma-ray bursts, rogue black holes, and yes, the inevitable, larger, faster interstellar object is infinite. Relying on a single point of failure, a single planet, is a fundamentally fragile and unsustainable strategy for a species with aspirations of long-term survival. The goal is to create a self-sustaining city on Mars. Not a base, not a flag-planting exercise, but a true, independent civilization. Why Mars? Because it's close enough to be reachable with current technology, and it offers the necessary resources, water ice, carbon dioxide, and sunlight, to become self-sufficient. Once humanity is multiplanetary, the risk of a single event wiping us out drops to near zero. If a 3I Atlas-sized object hits Earth, it's a catastrophe, but the human story continues on Mars. If a supervolcano erupts on Earth, Mars survives. If a global pandemic wipes out 99% of the population on one planet, the other planet serves as the ultimate backup drive for human consciousness and civilization. This is the long game. It's not about escaping Earth, it's about securing the future of consciousness. We are the only known example of self-aware life in the universe. We have a moral imperative to ensure that this fragile, precious spark of consciousness does not go out. The Mars effort, the Starship development, and the planetary defense system are all interconnected. They are all parts of the same grand project to ensure the long-term survival and expansion of life. Starship is the bridge. It's the vehicle that can deliver the deflection payload to save Earth, and it's the vehicle that can deliver the colonists and cargo to build the Mars city. The timeline is critical. We need to get to Mars and achieve self-sufficiency before the next major existential threat materializes. And the threats are not just cosmic. They are terrestrial as well. AI risk, engineered pandemics, and global conflict. All of these risks are compounded by the fact that we are all on one basket. The conversation with the Rogan often circles back to this fundamental point. What is the purpose of all this technology, all this wealth, all this human ingenuity? It's not just to make better cars or faster internet. It's to solve the ultimate problem, the problem of extinction. We are in a race between the development of a multiplanetary civilization and the next great filter event. The 3I Atlas comet, even as a near miss, is a stark reminder of the urgency of that race. It's a cosmic alarm clock. We need to wake up, deploy the shield, and build the lifeboat. The future of humanity depends on it. The existential filter, why we must look up. Let's delve deeper into the psychological and societal inertia that prevents us from taking this threat seriously. It's not just a political problem, it's a deep-seated cognitive bias. We suffer from what psychologists call availability heuristic and neglect of probability. We worry about things that are vivid, immediate, and easily recalled. A plane crash, a terrorist attack, a stock market crash. An asteroid impact, however, is a low-frequency, high-magnitude event. It hasn't happened in recorded human history, so it's not available in our collective memory, and our brains discount the probability, even when the consequences are infinite. I speak to the Rogan about this because he understands the primal, visceral nature of risk. He gets that the human mind is a flawed instrument for assessing long-term, nonlinear threats. We're essentially cavemen with smartphones, still reacting to shadows on the wall. The shadow we should be reacting to is the one cast by a multi-kilometer rock hurtling toward us at 50 kilometers per second. The media, too, plays a role in this failure of imagination. They cover the 3I Atlas story with a sensational headline, then quickly pivot to the latest celebrity gossip or political scandal. The story is treated as a curiosity, a momentary scare, not as a fundamental, ongoing threat that requires a permanent, multi-billion-dollar infrastructure. This is a failure of journalism to prioritize the truly important and terms. The news cycle is optimized for novelty and conflict, not for long-term collective risk mitigation. Consider the cost-benefit analysis. The total cost of a fully operational, Starship-enabled planetary defense system, including the development of the interceptor payloads, the establishment of a dedicated orbital surveillance network, and the maintenance of a rapid response launch capability, would likely be in the tens of billions of dollars over a decade. That sounds like a lot, but it's less than the annual budget of many single government departments. It's a fraction of the global military expenditure. The benefit, however, is the preservation of the entire human economy, all human culture, and the continuation of the species. The expected value of preventing a civilization-ending impact is quite literally infinite. Any rational actor, any rational civilization would make this investment immediately. The fact that we don't is a sign of a deep systemic irrationality. We need to shift the paradigm from last alert system to first strike prevention. We need to be able to detect these objects when they're still in the outer solar system, when they're faint, cold, and moving slowly relative to the sunday. This requires a dedicated space-based infrared telescope, perhaps positioned at the Sun-Earth L1 or L2 Lagrange points, or even better, an array of telescopes in deep space. These telescopes would be specifically designed to look for the faint heat signature of a dark, fast-moving object against the cold background of space. This is a solvable engineering problem, but it requires a commitment of resources that has not yet been made. The current approach is reactive. We wait for the object to come to us, to get close enough to be seen by ground-based optical telescopes. This is like waiting for the burglar to enter your house before you call the police. We need to be proactive. We need to be looking for them in the cosmic neighborhood long before they enter our inner solar system. The conversation with Rogan was about injecting a dose of reality into the public discourse. It's about saying, look, this is not a drill. This is not science fiction. This is a real, measurable, and statistically certain threat. The fact that 3 Atlas was an interstellar object, a traveler from the void, only amplifies the urgency. It tells us that the threat is not just local, it's universal. We are not safe in our little corner of the galaxy. We are exposed, and we need to build the shelter. The time for complacency is over. The time for action is now. Let's continue the deep dive into the physics, because understanding the mechanism of destruction is key to designing the defense. The energy calculation I provided earlier, the 17 million megatons for a 3 kilometer, 50 kilometers per second impact, is a staggering number. But we need to understand how that energy is partitioned and what the cascading effects are. When the impactor hits, the first phase is the contact and compression phase. The object and the target rock are compressed to immense pressures, far exceeding anything in the Earth's core. This compression is so intense that the rock behaves like a fluid. The impactor and a large volume of the target rock are instantly vaporized, not just melted, but turned into a superheated plasma of rock vapor. This vapor plume expands outward at supersonic speeds. The second phase is the excavation phase. The shock wave propagates outward, creating a massive, bowl-shaped transient crater. The material is ejected ballistically, forming a curtain of debris that rises high above the atmosphere. For a 3-kilometer impactor, the transient crater could be 30 to 40 kilometers wide and several kilometers deep. The subsequent collapse of this transient crater forms the final, much wider but shallower crater structure. The third and most devastating phase is the global environmental catastrophe. This is where the energy partitioning matters. A significant portion of the energy is converted into seismic waves, causing massive earthquakes globally. The magnitude of these quakes would be far beyond anything ever recorded, potentially exceeding magnitude 12. These quakes would trigger landslides, volcanic activity, and structural collapse across the planet. The initial blast creates a massive global shockwave that travels around the planet multiple times. This shockwave would be powerful enough to flatten forests and structures hundreds of kilometers from the impact site. Thermal pulse and global firestorms, this is the primary extinction mechanism. The material ejected from the crater re-enters the atmosphere globally. As the superheated ejecta, a rain of incandescent glass and rock plunges back through the atmosphere, it heats the air to incredible temperatures. The thermal radiation from this global re-entry ignites every flammable material on the planet simultaneously. We're talking about a global firestorm that lasts for hours, consuming forests, grasslands, and cities. The resulting soot and smoke plume is what blocks the sun. Impact winter, the massive plume of soot, dust, and sulfur aerosols injected into the stratosphere blocks out 90% or more of the sunlight. This is the impact winter. Global temperatures plummet. Photosynthesis, the basis of the entire food chain, shuts down. The darkness and cold last for months, potentially years. Most plant life dies, followed by the herbivores, and then the carnivores. This is the true end of the world as we know it. Ocean impact specifics. If 3I Atlas hits the ocean, the tsunami is only the beginning. The impact would instantly vaporize a massive volume of seawater, injecting hundreds of trillions of tons of water vapor into the atmosphere. Water vapor is a potent greenhouse gas. While the initial dust and soot cause cooling, the long-term effect of the water vapor and other gases, like carbon dioxide released from vaporized carbonates, could lead to a runaway greenhouse effect once the dust settles. The planet could swing from a deep freeze to a scorching hot, high-humidity environment, making life for any survivors nearly impossible. The sheer complexity of this cascading failure is why the threat is so hard to grasp. It's not just a big explosion, it's a complete systemic breakdown of the Earth's climate and ecological systems. It's the ultimate nonlinear catastrophe. And again, the interstellar nature of 3I Atlas means we have to consider the possibility of a non-standard composition. If it's a much denser object, say a core of pure iron nickel, the mass for the same size is much higher, and the penetration depth into the Earth's crust is greater. This could lead to even more catastrophic effects, potentially triggering massive volcanism or even a complete resurfacing event. The uncertainty is the risk multiplier. We must assume the worst-case scenario and prepare for it, because the cost of being wrong is the end of everything. This is the reality. I speak to the Rogan about the cold, unforgiving mathematics of cosmic mechanics. Let's expand on the three critical differences of interstellar objects ISOs and why they necessitate a complete overhaul of our planetary defense strategy. 1. Detection and warning time, the needle in the cosmic haystack. The problem with ISOs is their trajectory. They are not confined to the ecliptic plane, the relatively flat disk where all the planets and most asteroids orbit. They can come in at any angle, from any direction. This makes them incredibly difficult to spot. Our current surveys, like ATLAS and PAN-STARRS, are optimized for looking along the ecliptic, where the local threats are. Looking for ISOs is like trying to find a needle in a cosmic haystack, and the needle's moving at hypervelocity. The key to early detection is to catch them when they are still far away, before they get close to the sun. A comet like 3I, Atlas is dark and cold in the outer solar system. It only starts to brighten and develop a visible coma as it gets closer to the sun, and its ice sublimates. By the time we see the coma, it's often too late for an effective deflection mission. We need a dedicated deep space surveillance system. Imagine a constellation of small, highly sensitive infrared telescopes, perhaps using the Starlink bus architecture, positioned far from Earth's thermal noise. These telescopes would constantly scan the entire sky, looking for the faint heat signature of an object that is not following a known local orbit. This would give us the crucial years of warning we need. If we can detect a 3-kilometer object 5 years out, we have a chance. If we detect it 6 months out, we are essentially doomed. The warning time is the most valuable commodity in planetary defense. The other issue is the sheer number of them. We've only found 3 confirmed ISOs so far, Oumuamua, Borisov, and 3I Atlas, but that's only because our current systems are so poor at finding them. Statistical models suggest that there are millions, perhaps billions, of these objects passing through our solar system at any given time. Most are small, but the sheer volume means that the probability of a large one eventually hitting us is much higher than previously thought when we only considered local NEOs. The universe is constantly bombarding us with samples from other star systems. Into velocity and energy, the non-negotiable physics. The velocity factor is non-negotiable. It's pure physics. The fact that 3I Atlas is moving at speeds up to 70 kilometers per second means that any deflection mission must also be high velocity. To intercept an object moving that fast, you need a spacecraft that can match or exceed that speed, or at least meet it at a high relative velocity far from Earth. This is where the Starship's in-space refueling capability is not just an advantage, but a necessity. To achieve the necessary delta V for a high-speed intercept, the spacecraft needs to carry an enormous amount of propellant. A single-stage launch cannot do it. You need to launch the Starship, refuel it in orbit with multiple tanker flights, and then use that fully fueled vehicle to execute the massive high-energy burn required to get on an intercept trajectory with the ISO. This is a multi-launch, multi-week operation that requires a robust operational Starship fleet. Furthermore, the high impact velocity makes deflection much harder. The faster the object, the less time you have to apply a force to change its trajectory. A small nudge applied years out can be enough for a slow-moving NEO. For a fast-moving ISO, you need a much larger, more immediate force. This pushes the solution space toward the nuclear option or a truly massive kinetic impactor. The margin for error is razor thin. If you miss the deflection window, even by a few days, the object is locked onto its collision course, and there is no second chance. 3. Composition and structure. The unpredictable material. The Oumuamua incident is the ultimate example of a compositional wildcard. Its strange, elongated shape and its non-gravitational acceleration, it sped up as it moved away from the sun, as if it were being pushed by a small, continuous force, defied all known natural explanations. The most plausible natural explanation was that it was a hydrogen iceberg, but that's highly speculative. The possibility that it was an artificial object, a light sail, or a piece of debris is unsettling but cannot be dismissed. With 3, IATLAS, while it looks like a comet, we still don't know its internal structure. Is it a loosely packed rubble pile, or is it a solid monolithic body? This matters immensely for deflection. A kinetic impactor hitting a rubble pile might just absorb the energy and shatter, creating a swarm of smaller, still lethal objects. Hitting a monolithic body would transfer the momentum more effectively. We need to be able to characterize the object's internal structure remotely, perhaps using radar or active seismic experiments, before we commit to a deflection strategy. The fact that these objects are samples from other star systems means they could contain elements or compounds that are rare or unknown in our solar system. This could affect their density, their melting point, and their response to a nuclear blast or a kinetic impact. The uncertainty is a massive engineering hurdle. We need to develop a suite of deflection technologies, kinetic, gravity, tractor, and nuclear, and have them all ready to go, so we can choose the right tool for the specific object we are facing. Relying on a single, unproven method is a recipe for disaster. The interstellar wildcard is the ultimate test of our engineering and scientific preparedness.